Hey everyone, so this is Solving Systems. We're going to talk about two different forms today, substitution and elimination. So first, just want to go through what substitution is. Substitution is basically when you can isolate one variable, and isolate just means get it by itself. Right? And then elimination is where we typically use it when the variables might line up one on top of the other. Okay, so if they line up x's and y's, then you're probably going to want to use elimination. Now, the way I'm going to show you today, you can use either of these at any time. Okay, so if it doesn't specify which way you have to solve, pick which one you're more comfortable with. But typically there's going to be one that's going to be easier than another, so just keep that in mind. As you practice, you'll probably see which methods you want to use, and then go from there. So let's go ahead and start with substitution. So this is just our first example, and I wrote out the steps for using substitution here on the side. So first is you want to make sure that you solve for a variable. So you just want one equation so that it's a variable equals everything else. Now if you notice here in this example, none of these variables are on their own, okay? But we can make them so that they're on their own. So maybe I go ahead and I solve for y in the second equation. So to do that, I'm going to add x to both sides. So that makes these x's cancel and I get y equals x plus 1. Right? They can't combine because this is an x and this doesn't have an x. So now I have an equation that's solved for a variable. Check 1. Okay, so then it says substitute the equation from step 1, so what we just got, into the other equation and solve. So what that means is you're going to take whatever the y is equal to, so this x plus 1, and I'm going to plug it in wherever I see a y in the other equation. So when I do that, I'm going to have 4 times x plus 1. So I replace the y with the equation, right? And then equals 8 minus 3x. So now what I have is an equation that's all x's, so now I can solve it. And that's why you get rid of the y and you replace it with the other thing, okay? So now we can go ahead and solve this. I distribute the 4. We get 4x plus 4 equals 8 minus 3x. And now I'm just going to go ahead and start solving for x. So I could add 3x over. Okay. These cancel. I get 7x plus 4 equals 8. And then I'm going to go ahead and subtract 4. So we get 7x equals 4. And then lastly, I'm going to divide by 7. So when I do that, I get that x is equal to 4/7. Okay, so there's the first part. Well, now it says step 3, I need to solve by substituting the x value back into an equation. Now it doesn't matter which equation you use. You can pick whichever one you're more comfortable with. So let's just say I picked this top one. Okay, so I'm going to take my x value and I'm going to plug it in wherever I see an x. So 4y equals 8 minus 3 times 4/7. Okay, so now I'm just going to go ahead and simplify what I have. So you could take 3 times 4, that's 12, so we get 4y equals 8 minus 12/7. Okay, and then you could simplify this. Okay, so you guys can do that, and actually, if we made this into a fraction, I'm going to just do it off this side. 56/7 is the same as 8 minus 12/7. That's going to get you 56 minus 12, that's 44 over 7. So we have 4y equals 44 over 7. And then lastly, we're going to divide by 4. So we get y is equal to, and let me go ahead and type this in my calculator. So 44 divided by 7 is roughly 6.3. When we divide that by 4, we get 1.57. So and I'll round it up to 1.6. All right, so you've got your answer as x and you got your answer as y. The very last step, I'm going to write this in red, is to write it as an ordered pair. So we have 4/7 over, and then comma 1.6. And if you wanted to write both of them in fractions, both of them as decimals, I don't really care. It's however you are more comfortable with it. If you wanted to write 4/7 as a decimal, that would be 0.6. Okay, so this right here is your final solution. Okay, you want to make sure that you double check those solutions, but you're getting an ordered pair for your answer, and that's really important. All right, so let's look at some other examples. These might work out a little bit nicer. Example 2 says we have y equals 2x minus 9. Well, the step 1 is already taken care of because it's a y equals, so it's by itself. So I'm just going to take this 2x minus 9 and I'm going to plug it in where I see the y. So I get negative 3x equals negative 15 minus, and then 2x minus 9. Make sure that whatever you plug in, you put parentheses around it because you might have to distribute later, and you don't want to forget to distribute all the way across. So in this case, I'm going to simplify. and I'm going to distribute this negative all the way. So I get negative 2x and then positive 9, because negative and negative make a positive. And now I'm going to simplify. I'm going to have negative 3x equals, well, negative 15 plus 9, that gets you negative 6, and then minus 2x. And then I'm going to add 2x to the other side. Those cancel. So I get negative x equals negative 6, and then when I divide by negative 1, I get x is positive 6. So there's my x value. I've done step 2. Now I need to go back and find my y value. So I'm going to take this 6, and I'm going to plug it back into my equation. So I'm going to have y equals 2 times my x value minus 9. Well, y is equal to 12 minus 9, and 12 minus 9 is 3. So I've got my y and I've got my x. So final step, write it as an ordered pair, 6, 3. All right. Let's try this one together, and then I'm going to have you try one on your own. Okay, so this one here, it is not solved on its own, so we're going to go ahead and do that. So I'm going to get the x by itself. And like I said, it doesn't have to be y every time. It could be x. It doesn't matter. So I'm going to subtract 8y over. So I'm going to have x is equal to negative 8y plus 10. Okay, and so now I'm going to take this negative 8y plus 10 and plug it in where I see the x. So I get negative 3 times negative 8y plus 10 minus y equals negative 30. Now I'm going to simplify. Negative 3 I'm going to distribute all the way across. 24y minus 30, and then minus y equals negative 30. Okay. If I combine like terms, I get 23y equals, I'm adding 30 over to the other side, and I get 0. So if I divide by 23, I get that y is equal to 0, which is okay. You can have y equals 0. So then my next step is to plug my y value in wherever I see a y. And I'm just going to pick this equation, x equals negative 8 times 0 plus 10. Like I said, you can pick a different equation. It doesn't matter to me. You should get the same answer no matter which equation you pick. Negative 8 times 0 is just 0. 0 plus 10 is 10, so x is going to equal 10. So my ordered pair, final answer, is going to be 10, 0. Right? So let's go ahead. I want you, we're going to talk about elimination first before we have you do some on your own. Elimination, most of you guys will like elimination better because everything lines up nicely. Elimination is when your x's and your y's and your numbers are all lined up. So what you see here is that I have the x's in one column, the y's in a column, and then my constants in a column. So when you have an elimination option, what you want to do is pick a variable that you want to cancel. And the best way to choose which variable to cancel is to figure out which one have the same numbers in front, okay, and opposite signs. Alright, so in this case, my y's both have a 1 in front of them, and one's negative and one's positive. So those are what I'm going to choose to cancel. Alright, so now what I'm going to do is just add vertically. Okay, so I'm adding. What's 2 plus negative 3? Well, that's negative 1x. If I add negative 1 plus 1, these cancel, so I have no more y's. And then 9 plus negative 15, that's negative 6. So now I just have a simple equation with x in it, and I'm going to divide by negative 1. And I get x is equal to positive 6, right? And then the process from here on out is very similar to the substitution. Once you've gotten one variable, you're going to plug it back into one of the equations and solve for y. So let's just pick the top equation. So we'd have 2 times 6, because that's my x value, minus y equals 9. So we have 12 minus y equals 9. When I subtract 12, I get negative y equals negative 3. And when I divide by negative 1, I get y is equal to positive 3. So I have my x and my y, so my final solution is going to be 6, 3. Okay, and you always want to double check and make sure that that ordered pair works. Just plug both points back into the equations and make sure that you get the right answer, and then you should be good to go. Alright, so I'm going to do number 2 with you, and then I want you to try 3 on your own. So in this case, what you should notice is that the x's, y's, and constants are all lined up. That's perfect. Okay, but there's no numbers that match and that are opposite signs. So in these types of situations, you're going to have to make it match. So in this problem, I would go ahead and look at the x's, because what you notice is that the x's are already opposite signs. This one's negative, this one's positive. So what I need to do is multiply the top and bottom by a number or two different numbers so that the x's will match. Well, what's a number that 3 and 10 go into? Well, they both go into 30, so I'm going to multiply the top by 3 all the way across, and I'm going to multiply the bottom by 10 all the way across. So if I go ahead and do the top one, 3 times negative 10, that's negative 30x. 8 times 3, that gets you positive 24y. And then we have negative 16 times 3. Okay. Oops. Negative 16 times 3, that's negative 48. Just making sure I got my signs right. Okay. And then I'm going to do the same thing for the second equation. So 3 times 10 is 30x. 1 times 10 is 10y. And then 15 times 10 is 150. So now what you should see is that my x's match and they're opposite sides, so now I can go ahead and add them. So when I add them, my x's cancel. 24 plus 10 is going to get you 34y. And then 150 minus 48, or negative 48 plus 150 gets you 102. Okay. And now I can go ahead and divide both sides by 34. And when you do that, you get that y is equal to 3. So there's my y value. Now I can go ahead and plug my y value into one of these equations. I'm going to pick the second one this time. So we have 3x plus 3, because that's my y, equals 15. And I'm going to go ahead and solve for x. So 3x equals 12. Divide by 3, you get x equals 4. So I have my x, I have my y. So my answer, my ordered pair, is 4, 3. So please pause the video, try example 3 on your own. What you should notice before you start is that the x's and the y's are not on the same side. So you need to move a y or an x over something so that they're all on the same side and they line up. Then you can go ahead and cancel everything out that you need. Alright, so I went ahead right here and I moved this 2y over by subtracting it over to the other side. By doing that, my x's and my y's line up, and then my constants are on the other side. And what you should notice is that the y's are already ready to cancel. You don't have to do any multiplying, they're ready to go. So I'm going to add both columns. So x plus 10x is 11x. My y's cancel each other out, and I get 11 plus 22, that's 33. Dividing by 11, we get x is equal to 3. So you should have gotten x was 3, and then when you plug back into your equation, I'm just going to pick the top. 3 plus 2y equals 11. We get 2y equals 8, and we get y is equal to 4. So my ordered pair for this one should be 3, 4. Okay, so if you didn't get that, see where you might have made a mistake. If you're still stuck, make sure that you ask for some help. I just want to talk about real quick these two equations. If you want to try them for some extra practice, that's fine. But what you should notice is that these are dealing with decimals. You can always deal with decimals the same exact way because really the constant doesn't matter. It's just the x's and y's. So you would just have to pick the best method you would like in order to solve these. So I would suggest for this one, because the x's and the y's are lined up, I would go ahead and use substitution. All right, or not substitution, sorry. Elimination. There we go. So when they're lined up, it's always a good choice. For the second one, we already have an x that's by itself, so why not go ahead and just do some substitution? Okay, even though you're going to have some decimals, it'll still work out for a number. So you could plug that equation for x in and then solve for y from there. So this one I would do substitution. Alright, so if you choose to do elimination, that's fine. You'll get the same answer. It just may not be as pretty and as easy as using one versus the other would be. Alright? So if you have any questions, make sure you ask. If you need some extra practice problems, always ask me. I'm ready to give you some. Otherwise, you should be good to go on the practice problems. Thanks for listening.